Good morning, everyone. Afternoon if you're in Europe. Welcome to Allcore Dev 131. Pretty packed agenda today. A ton of upgrades around the merge. So some Kintsugi stuff, then Kiln, the new meta spec leading to a testnet. And then lots of Shanghai discussions as well. There were a lot of people kind of with EIP proposals, and I think kind of before that, we probably want to have a higher level discussion about generally how we want to shape Shanghai and like the various kind of potential things we could do in them. And then a couple announcements at the end. First up, I guess on the Kintsugi side, Perry shared an incident report in the comments of the agenda about the issue that we saw in the network. I don't know if you just want to take like a minute to kind of walk through it, Perry, and like what the high level issues were and kind of the state of things now.
Sure. So the high level issues was in the beginning, we had an invalid block that was causing an issue with Nethermind and Besu because they were missing a check. The invalid block led to a network split, and one being on an invalid block, one being without the invalid block, and one set that went into an optimistic sync mode. When we deployed a fix for the invalid block, we realized that the fuzzer had created another block that triggered another issue in Geth, causing some nodes to fail to be able to even sync. And once the get issue was fixed as well, then we noticed a few smaller edge cases in some of the clients. Once everything had settled down, we pruned some forks, got all of the nodes back onto one fork, and afterwards we were able to get the chain back on track. There's a deeper summary as well as implications in the incident report. I'll just post it here again for whoever wants a quick link. Yeah, that's about it, I think.
Got it. Yeah, thanks for sharing. So yeah, the link is in the agenda. We'll add it. We have somewhere in the execution spec repo where we track like these various incidents, like the testnet issue we had at London, for example. So it can just kind of be there forever for people interested. But yeah, thanks a lot for putting that together, Perry.
I'd say if you're working on Hive or other simulation tests, make sure to comb through this and see what scenarios you can pull out of it. Obviously, it's all generally fixed, but it's good to not have a regression.
Yeah, good point. Cool. So I guess next up on the agenda, there were the Kiln specs released last week. I guess maybe it's worth it for Danny or Mikael to just like take 30 seconds to walk through like the main changes. And then yeah, there's a couple things after that that are still pending for like an upcoming iteration of the spec. But yeah, Danny, do you want to just, or Mikael, do you want to just give a quick overview of the change?
Yeah, I can talk about the consensus layer. Mikael can pick up the execution layer. There are two PRs that were merged on the optimistic sync spec. This is when the beacon chain is kind of churning while the execution layer is still in some sort of sync mode. This is not, although it was just merged and just released, it's not new. A lot of client teams have been working on the implementation as the PR is up. Additionally, in the code base, merge was kind of a terrible word to have around and didn't fit the star naming. So it was chosen to go with a B star after Altair to Bellatrix merge. Merge the merge PR and things like that. It was kind of fun. And then a couple of very minor renamings, receipt route to receipt routes, just to match, I think, more of what it's actually called, maybe the yellow paper, and a modification of this other name to map to the engine API. Mikael, do you want to take the execution layer one?
Yeah, sure. So the major change on the execution layer side is the semantics change of execute payload and fork choice updated. They both now has a notion of execution, and for execute payload, it's been renamed to new payload, and currently execution is optional for this method call. Like it may be delayed until the payload becomes the becomes belonging to the canonical chain. So this is done. This was what was discussed during last few calls, and this is done to reflect the current logic of execution layer clients, basically. Also, there is the new handle for the case when the terminal block does not satisfy the terminal block conditions, which is a minor change. And yeah, message ordering refinement that has been done like a long time ago, but yeah, a while ago just, and this has been released in this version. So that's it. Also, the out indication, yeah, we can speak about it in the next item, right?
Right. Yeah. Okay. Yeah. So those are the changes up to now. I guess one thing I wanted to clarify also for Kiln is like, are there any test vectors yet? And if so, yeah. Okay. So basically, like client's question, but like, what's the best way for client teams to test their implementations of these changes so far?
Is Marius here?
No.
Marius was talking about doing, and maybe he has, I'm not sure, and we should catalog the testing methods available, but he was going to cut some engine API test vectors from Geth in previous sprints. This is surface bugs, both in Geth and in other clients, kind of before we try to do some interop. So that's probably the minimum one that's going to come up. I don't know, like client, if how people are using merge mock in their processes. I know some clients kind of were, and some clients were not. So if anybody wants to speak up and say if merge mock is valuable to their iteration, let us know.
Isn't it used in Hive also, the merge mock?
I don't think so.
It's kind of been rewritten to be a better fitting with the Hive architecture.
Another reminder, anybody think merge mock in this sprint will be useful?
I think it will be useful.
Yeah, it's
Okay.
definitely useful. There's not a test net to participate in.
Okay,
It's definitely useful.
I will get it updated by Monday or Tuesday, if that's okay.
Yeah, sure.
Yeah, that'd be great. Thanks a lot.
Thank you.
Cool. Okay, so yeah, so we have the current V1 release of Kiln, some tests coming. There's 2 pending additions for an upcoming iteration of the spec. One, the auth for the engine API, and 2, a new API call get transaction configuration, which acts as a sort of heartbeat check between the EL and CL that they're upgraded and ready for the transition. Mikhail, do you have like a status on the auth for engine API?
Yeah, it's better to ask. Is Martin here on the call?
No, Martin's gonna be late. Yeah, that's why I asked you.
Okay. Yeah. So I think it's about to get merged pretty soon. So I've got some attention from Martin that it's like in the final stage. So
Got it.
we'll likely merge it. Yeah.
Okay.
Yeah, they were working on implementation, which I think they've done, and are happy with it. So if you haven't taken a look, take a look. But I think this is going to be merged probably by the time I wake up on Monday, hopefully.
Awesome. And then
Yeah, I think it's already ready for merge from my side. So just need to double check with Martin.
oh, and Martin just showed up actually.
Yes. Hello. I missed a bit of what needs to be checked.
Yeah, we were talking about the auth between the EL and
Yeah.
CL and how just progress is going on that. And I think Get is implementing it right now.
Yeah, it's not in any PR yet. There's still some work left to be done, mainly to make the client part. Yeah, I mean, it's not complicated. We just need to find a nice way to expose it.
Got it. Cool.
What do you think about merging the PR to the spec?
I have no objections to that. I don't know if you guys mentioned, but the last minute change that was done to it is to not expose the secret in any logs. Unless someone objects to this whole authentication scheme, I think we should go ahead.
Okay, I guess maybe we can leave a couple days for people to review, but like Monday or Tuesday, merge it in if there's no objections. Does that make sense?
Yeah, I have no objections by Monday. This thing's getting merged.
Okay, cool. And then the other change was adding this adding this get transaction configuration endpoint, which basically polls to make sure that the EL is actually ready for the merge. Mikhail, I just saw this is your PR. Do you want to give quick bit more context on that, or?
Yeah, sure. So basically, it's been extended with the not only polling but also providing CL's configuration for EL. So yeah, this method is just called with the main settings of transition configurations, which are terminal block hash and terminal total difficulty. And CL sends its local values to EL, and EL responds with the corresponding local values that it has in its configuration. And CL and EL both may match received configuration settings from the counterparty, and if there is a mismatch, surface an error to users. Also, it should be useful for infrastructures, for large infrastructures, which there could probably be a script that just queries every EL instance in the infrastructure and checks whether it's been configured correctly and whether it's ready for the upcoming transition.
Quick question we have in Fogchain is updated. If the head block hash is an empty hash, we just return status valid or invalid or whatever. We can, like, why do we need another method if we can just use the Fogchain updated with the empty hash?
Talked about it a bit. Fortran updated has like super overloaded semantics already, so this is to just have a clean thing that can be deprecated right after the merge. I mean, I could go either way, but Fortran updated is kind of a monster stuck already.
Okay.
Yeah. Also, it's not only like to check whether engine API is working or not. It's also to check the configuration, and the configuration on the EL side is going to be in a binary distribution, likewise on the CL side. So it's a matter of checking whether the client is up to date with the most recent release. In case if these parameters will be overridden. And yeah, that's also one of the use cases. It's probably a minor one, but still valuable to have these values exchanged with to clients and surface an error in case of mismatch.
I'm curious, I guess. So we have basically these two pending PRs. One of which will be merged kind of early next week. I feel like we might need an extra couple of days for get transaction configuration just because it's newer and maybe we need teams to like review it a bit more. So call it like, I don't know, late next week. I suspect we can have all the changes, like both these changes merge in the spec. Oh, Andrew, you have your hands up.
Yeah, I just want, if we make this change, I'd like to clarify what happens if the terminal block hash is not set. Like it's whether it's returned at all, like all zeros, or what happens, and also if there is if the terminal block hash is all zeros or not set, then what happens to the terminal total difficulty? Will it be like, should it return 0 or not, nothing?
If basically terminal block hash, if it's set, then it overrides the terminal total difficulty. You mean that what should happen when it's set, right?
So
by default, terminal block hash is all zeros.
Yeah. So in the API, does it return all zeros or nothing in JSON?
It should return all zeros.
And terminal block number then. And for terminal block number, it will return 0 or.
Yep.
Okay. I just think it just has to be like explicitly mentioned.
Yeah, I mean, and on timing, Tim, this has been going back and forth a bunch in the Discord. I think that if there are issues with this, they should just be surfaced soon, and that we should target a release with these 2 additional methods by like Wednesday.
Yeah, and I guess my question was, if we're going to start standing up like ephemeral devnets, do we want to wait until those 2 changes are implemented in clients? Like, is there value to having a Kiln v1 devnet, or given those 2 changes are probably not huge, should we just wait and have Kiln v2 be like the ideally final or feature complete Kiln spec and then launch devnets?
Martin, did you have something?
Yeah, I just wanted to point out regarding the auth thing, it's not tied to any network per se. I mean, it's something that is rolled out first in the execution layer. It's side by side, I suppose, for like a month or a release with what's already in the legacy. And then after, on the next release, remove the engine from the unauthenticated port. And during that time, the CL can start using the authenticated one at any point. So it's not like they need to rush to implement it on day 1.
Yeah, so we can do all of our NRAP experiments with and without auth as people are kind of rolling out auth. And then the exchange transition configuration is probably one of the simpler methods to implement. And I would say that we should just release and get it implemented. Also, if there was no call, if it was not implemented on one CL, but it was implemented on EL, EL might complain that maybe configuration is not set or it's not hearing anybody, but also as the transition comes, they would still be able to communicate. So neither of them really put like a hard blocker on the core of the functionality here.
Okay, so does that mean, I guess we can probably launch DevNet like next week with whatever clients have something ready, and obviously the week after that do another one with
agreed. Rollout V2 is really an extension of V1, not a breaking of V1, and anyone that's ready next week, we should begin some interop experiments and super transient DevNet.
Cool. And I guess I'm curious, generally do teams have a feel when they're ready for that, just to help like Perry and others kind of coordinate there? If not, we can chat about it in the Discord. Let's do that. So once you have something that you think can work on a DevNet, reach out to Perry, just message in the merge general Discord, and we'll get a first iteration next week with whoever's ready, and grow that the week after.
Oh, and Marius, you did join. Are you going to cut some test vectors on the engine API against guests?
Yeah, so we had a bigger refactor of the sync, and so I had to rebase. So I implemented Kiln before that, and I had to rebase it now, and I managed to fuck some stuff up. So we have some regressions in the code against the test vectors, but I'm going to create some new ones. I'll be on holiday next week though, but I'll be still doing that. So yeah, nothing changes.
On holiday, but still working. Okay, it's not the end of the world if they're not there next week. Don't burn out. But yeah, we'll be waiting for those from you in the next couple weeks. Cool. Anything else on Kiln or the merge implementations so far?
I have a very small thing related to Engine API. There is the statement in the spec, in the Engine API spec, that ETH namespace of JSON RPC API should be exposed to the same port to provide consensus layer client with ETH functionality that is needed for to pull ETH1 data. And there is a suggestion to restrict this like broad requirement to have instead of it a subset of ETH methods that are required by consensus layer clients. Just wondering, what do people think about it? Is there like strong opinions on why should we have a list of methods instead of like entire ETH namespace? If there is no, because we will just keep it as is in the spec and will not make any changes.
So the ETH namespace currently is not well specified. Like there's work going on to try to get it well specified, but like clients are inconsistent between each other on what they return, how they return, how they deal with certain situations. It'd be nice if we don't port that forward to communication with the consensus layer. I would much rather see us have a much more narrow but very well defined spec for what is required for communicating with the consensus client.
Problem here is that consensus client might have different subsets of methods that they use, that they rely on, and probably there will need to be the functionality of CL client will need to be extended in the future, and it will probably depend on one of the ETH methods that is presented in all EL implementations, but is not in this list. In this case, we will have to update the Engine API spec to provide CL with this kind of method. Having this like broad definition makes it easier. So these are like points.
I feel like what you just described is the right way to go about it. Like if we need to, if some new feature is needed for the communication between the two layers, I feel like the proper way to go about that would be to come to a consensus on it, get agreement on what that method is, how it's defined, specify it well, and then have people implement it, rather than just kind of being like, hey, we've got this giant pile of data that maybe some clients implement, maybe some don't, or maybe they implement it differently, we don't know, and then we run into problems later because we're relying on that kind of old thing that isn't well specified.
Yeah, I think I agree with Micah. It'd be good to enumerate which methods clients are using. I don't think that there's going to be like a huge disparity between the clients, and this endpoint's supposed to be used for very particular things, so it's probably good to have it well specified.
I think
but I don't have the knowledge to enumerate those myself.
The other weak argument is just that if someone's building a new execution client, they may not immediately implement the full ETH consensus layer, and knowing exactly what is necessary to be a valid execution client in order to work with the consensus layer, but not necessarily everything to provide a full JSON RPC is valuable. So just knowing what the set of requirements are so that you can be confident you will work with all of the consensus clients.
Good point. Okay. I was like assuming that what is listed on the ETHWiki JSON RPC API is kind of presented in all clients and supported by all clients.
Yeah.
So, and this is the
So-
subset that the CL client may rely on.
So what is on the, someone else might be able to correct me on this, but I believe what is on JSON RPC API was pulled mostly from Geth source code, and we have not yet validated that everything on there is available in all execution clients. Have not reconciled the differences. So, different clients will return slightly different things for each of those methods, depending on which client you're talking to, which is part of the problem here, is they're not well specified. And so you might get, just as an example, off the top of my head, I don't know if this is real, but like one client may send you a number formatted as a JSON number, another one might send it as a hexadecimal string. And so that's like a subtle difference that could very easily break something if it's not well specified.
Okay, so yeah, one of the way to do this is to just make a table of methods and ask CL client implementer teams just to fill it with.
And I echo Micah. It helps ensure that we make sure those are very well defined, as opposed to the whole namespace, which is still in flux.
Okay. Yep.
Cool. Anything else on that? Okay. Last topic we had for the merge. Last time we discussed testnets and what that would look like post-merge to ideally give the community a heads up so that they can start moving to testnets, which will be supported post-merge and not be fully surprised if some of them don't work after the merge. The high level, we kind of agreed to like saying we would want to have at least one testnet that has like a pretty fixed validator set, which is stable and people can just use as a kind of staging environment for their applications. And we'd also like to have ideally another one where maybe the validator set is not as stable and people and client teams can use as a way to test that their software works when, say, the network is not finalizing and stuff like that. Peter has suggested we fork Ropsten into the merge, deprecated shortly after, fork Sepolia, which is the new proof of work testnet, into the merge and use that as a new testnet. So we get the experience of forking Ropsten, moving from proof of work to proof of stake, but Ropsten has pretty big legacy, so deprecating it means we don't have to like carry that huge testnet. Sepolia kind of starts with a smaller state, so we can kind of reset there. For Gordy, which into the merge, we maintain that as well, and then Rinkeby would just not fork. There were a couple of conversations on GitHub about that, and generally, I think Danny, you agreed that Gordy Prater makes a lot of sense as a kind of
yeah, something that looks
stable,
close to mainnet and is stable.
Yeah, and then there was, I think, the other kind of concern is how do you actually do it on a stable testnet? So first, I think we discussed the idea of just like you have a public set of stakers, and then that means some of them will like will drop off and whatnot. Adrian in the Discord seemed to think that this is probably like a weak form of chaos, and we might be able to actually do better if we if the validator set is also pretty kind of controlled, and we can do things like periodically shutting down end portion of the validators and introducing forks and whatnot. So it's that by controlling actually the set of validators, we can be more mindful about how we want to kind of create chaos. And then there was also I think Nimbus worked on this Insecura testnet, so to like explicitly kind of test some attacks on the beacon chain. I guess generally the people agree with like the idea of having like one kind of at least one application stable testnet, which would be Gordy Prater after the merge, and then we'll have Sepolia as well. And I'm not sure how exactly, but to have kind of that one be a bit more chaotic in a sense. Does anyone have like, oh, Andrew, go ahead.
Well, it's my personal opinion, but I see value in having a hairy testnet like Ropsten. So I wouldn't kill Ropsten because though it's very hairy, it's a better reflection of the mainnet.
What part of it do you think is valuable to keep? When you say
well,
hairy?
the state, of course.
Gordy, I think Gordy state is probably as big right now, but it's maybe worth double checking that.
And I will note, I think I said this before, a tool at our disposal is a modified version of the deposit contract, which allows for the issuance of like a token. So it's gated. So we can essentially utilize the proof of stake mechanism with this contract as, you know, something that looks kind of like a proof of authority. So for a net that you wanted to do more structured, one, you know, make sure that the community can't overrun it, but two, also make sure that you control enough of the validators that you can you know, turn half of them off and on. This gating mechanism works well, and that would essentially kind of turns it to look like the way Gourley's clique works today in some sense.
Right. Okay. I don't think, yeah, we don't have to figure this out today. I do think it's valuable for teams to think about it and kind of share, you know, ideas. I saw Thomas, he just shared something in the issue. And generally, you know, I think pushing folks towards Gordy, Sepolia as very likely to be around after the merge. I don't see a reason why Gordy would shut down. So that one seems just obviously going to be around. Sepolia, very likely as well. Ropsten seems like there's kind of an uncertain future there. Yeah, so if you're wondering which testnet to deploy on, I think Sepolia and Gordy today are probably the most important one. Rinkeby, a lot of people deploy on, I think is the likeliest to be the first to be shut down. So if you do have your application on Rinkeby, you should start looking at moving over to other testnets. Any other thoughts, comments on that? Okay. Okay. So next up on the agenda, I guess to put this in context, on the last call we had very little time to discuss Shanghai, but we in the last couple minutes kind of brought up a series of EVM object format EIPs, so 3540, 3670, 3860, and both in like the last couple minutes of the call, and then I think shortly after in the Discord, there seemed to be like strong consensus that those three should go into Shanghai, or at least, you know, be moved to CFI, so we can start testing them on Devnet once we're done with the merge work, and then obviously seeing those three potentially going into Shanghai, a lot of people came up and proposed a bunch of other EIPs that they would like to see into Shanghai. So there's different EVM related EIPs. There's 3074. There's the whole thing about lowering call data costs, and so there's the EIP 4488 that we talked about, and Vitalik has a couple new proposals today. And then beyond that, there's obviously other things that like we'd like to do in Shanghai that we've mentioned, and people just like didn't put on the agenda for this specific call. But there's obviously the BLS precompile, and probably the other biggest one is withdrawals from the beacon chain, which does not have an EIP yet. So I think, you know, it's probably a mistake to like go over every single EIP and like in a ton of detail. And I think the fear that I have is to like say that like, you know, this and this EIPs are included in Shanghai, and then in two calls we say this one and this one, and in two calls we say this one and this one, and we get to a spot where like the merge is not even out yet, and Shanghai is already bigger than any other hard fork in history. So I guess I'd be curious to hear, you know, from just different client teams and whatnot, like high level, how do you think about like prioritizing things in Shanghai? Like what are like the, I don't know if it's like buckets or like most important things. And then from there, maybe we can like go into the yeah, go into the kind of different proposals. And actually, I'm happy to start with you. Actually, you have a comment, and I know there's like 4 or 5 different EIPs that are all kind of somewhat related. So yeah, if you can just kind of explain how they relate to each other and what the whole, call it like EVM improvement bucket looks like, that would be really, really valuable.
Can you guys hear me?
Yes.
Okay, so I would say there are like 3 different categories of those proposals. The first one is what I think should definitely go in as soon as possible, and I would start with the limit init code, limit emitter init code, which I believe maybe is 3855. That is not introducing a new feature. That is rather addressing a missing metering aspect of the system. But it also is kind of like a building block for the other changes, especially the validation EIP. And there's another one in the same category, which I think is 3860, that puts 0 instruction. This was also discussed like I think last year during the last potential hard fork, and that is a really minor EIP, but it would help Solidity quite a bit. So these 2 are one category. I hope this could go in, and they're kind of small and have been discussed. At least the limit init code has been discussed with the Go Ethereum team to some extent. The second category is just the baseline of the EOF, aka EVM object format changes. And that is only 2 EIPs again. So that's 3540, which defines the core proposal. It only introduces the code and data section and some basic rules around those, but it doesn't really introduce any opcodes or any other changes. And together with this is 3670, which is the code validation. I think these 2 should definitely go in together. And these have been around for quite a bit. And then the last category is the actual features. And there are 2 feature EIPs. One is the static relative jumps. I can't recall the EIP number now, but I think that is also quite stable. It would help Solidity and other languages to use static jumps for pretty much everything, with the exception of return from kind of like function calls, because those still need dynamic jumps. So the CIP just introduces static relative jumps and doesn't remove anything else. And then the last EIP is what we have been working on for the past, I would say, month and a half, but it actually started like half a year ago with an implementation in EVM1. And this is this function sections proposal, which is, I guess, quite a bit more complex than everything else I mentioned so far. It all depends on when Shanghai would come, but at this point, I'm not that hopeful that the CIP would be considered for that. But this would be the last stepping stone to actually get rid of dynamic jumps entirely. The static relative jump EIP and this function sections both have been discussed with the Solidity team, and they expressed interest, but it's still kind of early. So I think this is the summary from Epsilon.
Thanks. That's very helpful. I think it's probably worth it, yeah, to get a couple similar summaries from like different kind of people who propose stuff, and then we can have a more general discussion. Greg, you had basically 2 as well that are also kind of EVM improvements. So the simple subroutines and then the safer control flow. Do you want to take a minute to go over those?
Yeah, I'll try and be faster than usual. 2315 remains. responsive to criticism of the last one, it got pushed towards back to where it started and a little further as almost pure mechanism, and it's now static, and it's relative, and using the same conventions as the static relative jumps. So those get along together. And it's pretty much as fast as I know how to make a subroutine go, or as anyone's figured out for 75 years now. But the most important thing for me is the safer control flow, which is not a proposal for any opcodes. It's a proposal for an algorithm at validation time. So that's why it's very important to get the validation algorithms in, so that we can do other things like this. And we want safety. We never seem to know what it means. It can mean lots of things, but I explicitly define it here as a safe program does not encounter an exceptional halting state. And when it's Turing complete, you can't totally validate that. But if you follow reasonable rules, you can check a lot so that a valid program will only hit an exceptional halting state if they run out of gas or blow stack in a recursive subroutine call. And that can be established at validation time, given the other EIPs we have. So we have ways to do static jumps and subroutines. And given that if you're using the existing jump, that you use it in a static manner, which doesn't just mean that you have to push the address right before you jump. The algorithm can track the constants on the stack enough to say, oh, this one actually was pushed as a return address for subroutine, so it's okay. So that's a package that I think is important to basically get the level of safety we've been talking about for the last 5 or 6 years without imposing any further structure, any further opcodes, just an algorithm to run. So those are what are on the table for me.
Got it. Thanks for sharing. I think that the next one on the list was EIP 3074. I don't know, Matt, do you have any updates on that? Or I know we've spent a couple calls in the past discussing it, but yeah, has anything changed from the proposal for London, or is it still generally the same thing?
It's generally still the same thing. We've talked about adding an extra parameter into the auth opcode to allow it to be forward compatible with a world where we want to remove ECDSA as the default authentication mechanism for accounts. But generally the proposal has not changed since mid last year.
Cool, thanks.
The only other thing to mention is that we're having a couple thoughts on where we could go after 3074, and one is like a create3 or auth usurp, where you can deploy code and replace an EOA, and that's kind of something we're toying with, but that's like far down the road.
And those would like build on 3074 being the
exactly. So yeah, you put in 3074, it introduces the authorized address, and then you can build on top of that.
Is it the replace code with replacing the EOA with code thing not strictly dependent on 3074? Like,
no, we just have one way of doing it with 3074.
I see it. Right. Okay.
Got it. And then Vitalik, you had a comment about different, basically new transaction types, which could carry blobs of data and hence reduce rollups costs. There were 2 proposals. Do you want to take a minute to like walk through each of those?
Sure. So the 2 proposals are very similar. Basically, one of them like just does a little bit more plumbing work to move some stuff into the beacon chain that eventually needs to be moved into the beacon chain anyway. But the core idea of both of the proposals is that So today we have the execution blocks that have transactions, and those transactions have call data. And rollups today use transaction call data. In the future, we're going to have sharded data. And the way that it's looking like sharded data will be introduced is through this concept of blob carrying transactions, which is basically a new transaction type where there is a transaction header, which just looks like a regular transaction, except it also has a cryptographic polynomial commitment to the blob. And the headers of all the transactions would still be, like in the long term, would still be broadcasted, included. Everything would happen with them the same way as today. But the blobs would not be like passed around the main peer-to-peer network. They would be passed around with like sharded peer-to-peer stuff and the data availability sampling and all of that kind of technology. So the long-term goal is basically that sharding would, or that these blobs would give us a total space of like somewhere around 32 megabytes per block, and that could be used by rollups and like other kind of data-dependent applications. And this is 32 megabytes. Like this data would not be directly accessible to the execution layer because the intent would be that you should be able to like verify blocks without actually having the blobs. So like the intent would be to make the whole purpose of sharding is that it should be possible to have a network where you don't need any single actor to download all of the data. And so the blobs would be this kind of extra much bigger piece of data that gets committed to, but in the channel that everyone sees, but broadcasted through this different channel where not everyone needs to download it. So that's the long-term future of sharding, right? So the idea of both of these proposals is to bring forward the transaction format that would be used in sharding and basically implement it much more quickly, but don't yet do the actual sharding, right? So basically, we would have these blob transactions, and the contents of these blob transactions would be like, you would have the header, you would have the block commitments, you would have the blob, but the blob would still be kind of part of the transaction contents, and it would still be part of a block, and like everyone would still have to broadcast it and download it. But there are a couple of advantages. So one of the advantages is that it has the kind of EIP 4488 style benefit that there's a separate limit on the total amount of data in this scheme. So like a block can't have more than 2 megabytes, but there is a separate EIP 1559 update rule that makes sure that it stays like basically the fees adjust, and so until like usage really picks up, fees would be extremely cheap for it. And it also has this feature that the transaction execution actually cannot touch the blob the blob contents. It can only touch the blob header, which just makes it much easier to have like basically do things like forgetting the blob contents much more quickly, and like generally it makes it a much less of a burden than having like just having call data, where like it's more difficult to treat it because you don't know like whether or not some piece of execution depends on like accessing some random byte somewhere in the middle of it. So the there's two EIPs there. The simple version of the EIP basically just implements the transaction type, and it implements this in this very black boxy way. Basically, it just says there is a new EIP 2718 transaction type, and there is this kind of black box function that checks the blob and against the commitments in the header. And then there are a couple of precompiles that let you access the blob, or basically prove things about the blob. And those precompiles will be needed for optimistic rollups and ZK rollups to be able to actually interact with the blob data. The more advanced version does a bit more plumbing, and it basically moves the blob contents out of the execution chain and it moves them into the beacon chain. And this is something that we are going to have to do for full sharding down the line anyway. But basically the more advanced version of the CIP does this, basically does this immediately. And so the plumbing just immediately turns into, you have like this one transaction object that gets passed over the network, and then only the header gets included in the execution layer. And then the actual blobs and the blob headers would go into the, or the blob commitments would go into the beacon chain. And then there's like, eventually, once we do proper sharding and data availability sampling, it becomes much easier to kind of take the blobs out and start handling them in a different way. So I guess in terms of like when I would I would love to see these included. I personally see two possible paths, but there could be more. One of those paths is to try to do the simple version and get it included in Shanghai. It is possible, and this could be as an alternative to 4488. It is more complex than 4488, but it's still like totally within reach, within reach of implementability, and it's like much simpler than a lot of other things. The other possible path would be that if we decide that, I think if we decide that either of these is infeasible to do by Shanghai, then we could basically do the more advanced one possibly in the fork after Shanghai, and then still do EIP 4488 ASAP. And so basically we end up kind of doing both, of the stopgaps.
Got it. Thanks. That's really, really helpful. Sorry, just moving on because there's two more. So Denkrad, I know.
Can I highlight one thing?
Yes.
Vitalik, this requires a trusted ceremony to do the KCG commitments, correct?
Yes, correct.
So there's a dependency there.
Right. But that's that can be done by a completely separate group, and there's months to do it.
Absolutely. Absolutely.
Right.
I just don't want us to go down this path without acknowledging that needs to be possible.
Yep, agreed.
Cool. And so another big bucket, Denkrad. I know you've been working a lot on stateless, and there's a couple EIPs that would help lay the path for it. Do you want to walk through those quickly as well?
Sure. Yeah. So I added some EIPs that we kind of roughly started discussing earlier when I introduced the statelessness roadmap, where the general idea was we have some gas cost changes that we need to make for statelessness. And we want to get those in as early as possible, which is to get applications developers work in the correct model rather than continuing to deploy contracts that will be inefficient in the future model. And then introduce the Merkle partition, freeze the Merkle partition tree and replace it with, and add a Merkle trie commitment. And then as the third step to replace the frozen root with the Merkle trie root so that we can have full statelessness with witnesses for everything. And so the EIPs I introduced for that are 3058, 3060, and 3062. 3058 is about deactivating self-destruct. That's for me the highest priority overall. Like self-destruct, it has been discussed many times. Deactivating it, there are many good reasons for it, but particularly in the context of statelessness, where we will have the account storage separated from the root of the account, so they aren't like, there isn't really an easy way to access all that anymore. Self-destruct would become really complex to implement, so we really want to get rid of that. 3058 is a simple version which simply says replace self-destruct with send all, and it simply sends all the funds to the caller but does nothing else. So there has been an analysis. There's basically one major known contract that uses this, and there is an alternative way for them to be upgraded and to implement this. So that would be one thing I would suggest for Shanghai.
Question.
Yes.
Yeah, when you say one big contract that uses this, do you then refer to upgrade in place via self-destruct and then create two, or did you mean something else?
No, I do not. Does anyone use that? I'm not aware that anyone uses that. I think that the contract that I'm referring to is this Pine Finance contract. And what they do is they actually replace with the same code, but they currently, there's a problem that basically a contract that has been used is in a state where anyone can take the funds. So that problem can be fixed. Yeah. I'm not aware of any contract that upgrades using create2.
Yeah, but are you not aware because you've searched and not found, or?
Yes, someone has done the search for this.
Okay.
Yes. Yeah. That was a few months ago though, so I guess
right. This was like some, you know, like there was someone who like was like be explicitly assigned, like was it even a grant or something like that? Like basically the job of like looking for things that it would break, and they only found that Pine Finance thing.
So in terms of, so that's the only one. There were some others where the code was unknown, and the Pine Finance was the top one, the one with the major deployments that had. I don't think they went 100% through all contracts. So there's still a long tail of smaller contracts that someone might want to look through, but they are much smaller value and much smaller deployments.
Got it. By the way, after we're done with this one, I just reminded there's another breaking change that I think Dankred is important, the Virgil thing that we should talk about. But this is about the chunk gas costs. But maybe finish this first.
Right. Yeah. So if we are very concerned about like self-destruct, that we're going to break something when we introduce it, I wrote down an alternative version that's 3060 that basically ends like the end result is the same, but it goes through a phase where the self-destruct opcode gas cost increases exponentially over a few months. And so the idea is that it seems that many people in the Ethereum ecosystems don't watch out like for roadmaps and changes that will be introduced and so on. And that includes application developers. But in this case, anyone who still uses self-destruct would notice over those months that my gas costs are increasing exponentially. Maybe I should check what's happening. And they would hopefully have enough time to safely upgrade their contracts in that time frame. Or get all the funds out that are still in there, coordinate something. So that's 3060. It of course is a little bit more complex, but also not super complex. And yeah, would be an alternative if we think that there's like, yeah, we should give everyone ample notice and make sure that they will notice that something's happening. And then, so one of these two, I would really like to see included in Shanghai if possible. Then there's also 3062, which I've unbundled. Previously we had written it down as one, but that's the actual gas cost changes that basically introduces the witness costs for worker trees. What this basically does is it adds a new cost for accessing code. So that increases gas cost. And there's also a decrease in gas cost when you access adjacent storage slots or slots that will be adjacent with worker trees. And the latter means that that clients will have to have a certain database layout implemented in order to not make that a DOS vector. I think Guillaume is still in the process of communicating to all teams whether they will be able to achieve this. So this is definitely a somewhat deeper change, and so more complex than just deactivating self-destruct. And I guess like there has been the idea of just uncoupling them and just do the increases first, which clearly doesn't introduce a DOS vector. I think I'm not a big fan of that, because that, I think like application developers would be annoyed if we strictly increase all their gas costs without giving them anything in return. So if we can't do that, then we might just have to wait with those changes until the actual introduction of worker trees. But I think it's still interesting if the database upgrades are progressing well. I think this EIP should still be considered, because I think it's best to let applications become efficient as early as possible, because all the contracts that are deployed in the meantime are all very likely to going to be suboptimal once worker trees are introduced.
Okay, thanks.
Yep, that's it from me.
Okay, and I think this was everyone who posted something on the agenda. One thing I think that would be valuable, Danny, I don't know if you have, I know there's no EIP for it yet, but do you have a high level idea of what beacon chain withdrawals will imply at the execution layer?
Yeah, so essentially it's the exposing of a commitment to withdrawal receipts, and then the consumption of those commitments at the execution layer via a normal transaction, which would move the balance of that receipt into a contract or account specified in that receipt. So this is a precompile or a special contract or something that essentially a normal transaction can be hit with the proof of receipt against commitment and tracked there. The receipts are indexed, so as simple as a bit field in the state can mark the consumption of the receipts. I believe that Alex has a lot of this written down, and we're actually gonna be meeting in person next week and plan to have something of a draft to be shared by then. Really, it's commitment to receipts, consumption of receipts by a normal transaction, moving the ETH into an account, and then the tracking of consumed receipts.
Got it, thanks. And then finally, like, there's obviously people who didn't just post their EIP on the call agenda, and there's a couple like other valuable ones we've talked about in the past. 2537 keeps coming up, so the BLS precompile is one that people keep saying we should have. We had I think a couple calls ago a discussion about the transient storage opcodes, EIP 1153. And I know there's a couple others that have been pending for like a much longer time. I think Thomas, you were championing EIP 2937 to have I actually forget the title, sorry. Saving the historical block hashes in the state. 2930, sorry. So there are others as well. And so, you know, off the top of my head, there's probably like 15, maybe 20-ish that are being considered across like very different buckets. There's a couple comments in the chat about how anything that kind of increases throughput, reduces transaction fees is probably something we want to prioritize, whether that's a 4488 or a simple kind of mini sharding, I believe it was called. And yeah, and you know, everything else, like I think the EVM upgrades have been pending for a long time. I guess first of all, you know, I'd be curious to hear maybe from client teams, like what are you think like the top 1 or 2 things that are like most important for Shanghai? That's probably a good way to like start thinking about this. Yeah, and Andrew, I see you have your hands up.
Yeah, so because we desperately need scalability, I would say something along the line of blob carrying transactions is priority number 1, either in its simple or more complex form. And priority number 2 is the basic blocks of EVM improvements. So EP 3540, 3670, and 3860. So my understanding is that those 3 are kind of the basic building block. And priority number 3 is deactivating self-destruct, is in its kind of simple form, maybe, or maybe more complicated, but to deactivate self-destruct that would allow us to, that would simplify the EVM, would allow vehicle trends, things like that. Yeah, that's my take.
Thanks. Any other client team want to share your thoughts?
Yeah, I don't know if I speak on behalf of Get, though we haven't really discussed it internally. I would agree with what Andrew said, at least for the first 2. I agree about we need focus on scaling, but I have not really studied the whole blob proposal in depth. So I
think it's a new proposal. So
yeah, so I mean, in theory, I think it's great, but I need to look into it more. Also, I think the EVM improvement with the EUF, those first steps should be taken because they enabled so much more. Regarding self-destruct, I don't know if I agree with that. And I think there are a few that are pretty trivial to fix that I think maybe we could include as well. I'm not sure what else would be prioritized. I think, oh, yeah, one more thing I just wanted to mention. So this 3074, I know that there has been some opposition, not only from me, but also there's this counter proposal which would not introduce consensus changes by Joa Weiss and Vitalik. Maybe it's not time for that discussion now, but at some point I would be curious to hear the pros and cons of the 2 approaches. But we can, yeah, probably not time for that today.
Hey, you're talking about 4337, I think, like the account abstraction proposal?
Yeah.
Yeah, I don't think they're mutually exclusive. They just solve different problems. Yeah.
I think one of the big differences, just to put it in for 10 seconds, is that 4337 does not help people who already have EOAs, only people who will deploy new contracts under that paradigm.
Got it. I think that I've had this question asked several times, Sam and Matt. I think and I think Matt, you actually had a Twitter thread about this, but I think if either of you could write like a short HackMD document or something, just the TLDR, and post it in the 3074 discussion link. Oh, actually, this Nethermind already did it. So I guess Martin, you can read the post that Thomas just shared.
Yep, thanks.
Cool. So as Aragon Get, yeah, Thomas, I'm curious. Yeah, you've been sharing a lot of comments. Do you want to take a minute or 2 to walk through what you see like from Nethermind's perspective as being like a priority and useful?
So personally, I don't really have priorities. It's more about the sheer amount of all the different EIPs that we see on the list. It seems a long list, which is good that we're coming to good old times when you had those lists of 20 and so on, and we are filtering them down. I think it's up to community and others who actually are champions for those EIPs to say like why. And yeah, personally, I have no priorities here. Like the simple ones would be on my priority list, like if we all agree they are good to go, they're relatively simple to introduce and test. I think the ones that deal with the code, like the object model and so on, I would say, yeah, they go in. As for the ones with subroutines, I was thinking maybe, and I suggested that on that thread, that but this might be controversial, to split the conversations where the merge conversations happen between the if2 and if1 team on the all core devs, the merge call, and then we have the IP teams that work on pushing the modifications to EVM and execution layer clients. So those teams can work in parallel and don't feel that there is some kind of conflict between the merge effort, the merge work, and the IP's work. Those meetings would be even more efficient, and we would start seeing those teams. But since we, like, when you look at the list here, it's 40 people, and we have like these 2 separate parts of the meeting. So maybe there's a natural suggestion here that this is the way to go.
Yeah, I think I've been thinking about that. One of the challenges is that at the end, it is kind of blocked on the same people implementing it, right? Like, so we can have like separate meetings to like discuss the EIPs, but like you do want input from the client developers who will be implementing it. And I think it's probably not the end of the world if they kind of happen in parallel, just because like we are still, like, the merge is not done. It's not shipped yet. We still have time to like slowly kind of get into this stuff before we need to be, you know, solely focused on it. And I think it'll kind of maybe naturally happen once the merge stuff is done. Then we're not going to talk about the merge stuff anymore. We'll be like 100% on Shanghai. And then like when Shanghai is pretty done, we'll be like half on the next fork. So I don't know. Yeah, I need to think about it more. But I think there is like I agree. There's a lot of like EIP champions who like don't care about the merge stuff, but I'm not sure that the opposite is true, that like the people working on the merge can be kind of excluded from like the EIP discussions. Yeah. Oh, yeah, Thomas?
Maybe if you ask me about like pushing Ethereum the most forward with VIPs, then the blob transactions or something similar would be of the highest interest.
Thanks, that's useful.
Does your statement the same people are working on the merge as the EIPs? I agree the same teams are working on them, but I kind of have assumed that within the teams they had multiple people, and so it's not necessarily the same humans.
I think it's harder
to
fully parallelize than people generally assume. And you do end up, like, sure, some different people might write the code, but it gets merged into the same code base. People need to review this stuff. And so I don't know. I guess what would really change my mind here, if client teams all signaled that, hey, we can actually do like 2 fully separate tracks, and that's helpful. That I think that would change my mind. It's just like from client teams, that's usually not the feedback I've gotten.
Yeah, I was just gonna say you're probably not gonna have any client teams saying, "Hey, we can work on multiple tracks and do anything you throw at us."
Right.
Because there's always another multi-track, which is like maintenance optimizations and like all the things that aren't new features.
Yeah. Yeah, that makes sense. Thomas, is your hand still up? Is there like another comment, or did you just forget to? Oh, okay, just forgot. Cool. Besu, curious, yeah, what you all think about this.
So, roughly in agreement with what I've heard before. The EOFs, I think, are just foundational for solving a lot of problems going forward with a lot of things, particularly the things like the jump optimization, the jump table, the size, scope, separation of the data. Those have very subtle implications that I think will be long-term very valuable. My biggest concern is upstream adoption of these issues, specifically talking about things like the Solidity compiler, the Viper compiler. If they're not generating the features that are doing an EIP, then it's one point of view would be it's a little bit of a waste of time. The other point of view is we're not getting an extra category of test tries of what they're actually going to try in the field and in the wild. We can come up with great ideas and reference tests, but we really also need to test it with what's going to come down the pipe from the compilers. So of all of these things, the next question is also how on board is the Solidity team and the Viper team with these changes? Solidity has GUF implemented. Great. All the pieces, all 3 of the pieces, all 5 of the pieces, just the container. You know, those are the questions to come up with that. And so it looks like positive for the EOF stuff would be my take.
Cool. I guess, it seems like there is kind of a general agreement that like like the simple kind of first building blocks of EOFs, which I think are what we basically discussed on the last call, are high priority. That beyond that, like the blob transactions are potentially really useful, but there's a lot of unknowns. I think there were some comments in the chats about trying to prototype that at ETH Denver. And then the other thing, I think we probably have a slight bias here, is the beacon chain withdrawals, where I think from the like staking community, that's basically impossible to ignore. So I don't know, would it make sense in terms of next steps? I know like the first couple EOFs, I think it was, let me just check the numbers. It's like 3540, 3670, 3860, to basically move those three to CFI like we discussed on the last call. See over the next couple of weeks if the transaction, the blob transactions can be prototyped at ETH Denver, and how how complex it is, and what that actually looks like, and based on having more information, we can see which one of the two proposals might make sense for Shanghai, and if not, kind of revert back to 4488, or if there's something we need to fix, we'll have still a few months to fix it. And then I think also in the next, not necessarily a couple of weeks, maybe, we also get like a beacon chain withdrawal EIP, which we can look at. I don't know. Yeah, I guess summarize, like moving kind of I think this would be 3540, which is the EOF kind of core EIP, 3670, which is the EOF code validation, and 3860, which was limit and meter init code. Moving those to sort of CFI for being the first we would try out on DevNets in Shanghai, and then prototyping the blob transactions, and once we have a beacon chain withdrawal EIP, we can discuss that in more detail. If there's any strong objections, now's your chance. Okay, cool. So let's go with that. I'll put together a draft, basically spec for Shanghai, either today or early next week, which has those. I do think so. We're probably getting pretty late in terms of considering new proposals. I think if people have stuff that's completely new, like it was good to share them today, and there's probably one or two more calls where we can realistically consider new ideas. But it does seem like yeah, what's trying to prioritize what's in there. And I think once we also are a bit farther along with the merge work, and we're kind of waiting for it to happen on testnets and mainnets, we can actually implement these new things on devnets and see how much work they are, how much interplay there is between them, how complex it is to test them all. And I think that'll give us kind of a good idea of how much bandwidth we have if we do like some EVM upgrades, we add withdrawals, and something around basically transaction data costs. Yeah, beyond that, I think we can kind of decide once we've actually implemented stuff and have a better idea. Cool. No objections, so I'll take that. Yeah, I'll take that as a good sign. Two more final things before we wrap up. One is the Quilt team has been working over the past few months on an executable spec for Ethereum. Yeah, it's a really important piece of work. It would move us in line with how the consensus layer teams do that, and solve a lot of the problems we have when writing EIPs, where it can get awkward to specify the changes all in line in the EIP. Sam, do you want to take a couple minutes to walk us through this?
Sure, yeah. I won't take too much time. Do you want me to share my screen, or?
Yeah, if you can, go for it. And
okay.
We do have 10 minutes and kind of nothing else except an announcement, so you can go for it.
All right, so the execution specs are very, very similar to the consensus layer specs. The only difference is they're written in Python first and then compiled into HTML, as opposed to being written in Markdown. So here's kind of an example of what it kind of looks like from Spurious Dragon. It's very idiomatic Python. Well, it's actually very simple Python, very understandable, should be easy for most people to contribute to. We're kind of looking for feedback on how useful this would be for client teams, and maybe have a discussion at some point about how we want to change the EIP process. So this is the raw view of what it looks like. So you can kind of see how like validating a block header works. Now we haven't actually written the annotations yet. Nice thing about this is the annotations will be in line with the spec, but you can turn them off if you're an experienced user. So moving on to like what kind of the rendered specification looks like, it's Sphinx. We haven't done a lot of work on the theming yet, so we can definitely make this look better. But yeah, it's searchable, it's navigatable. You could actually get links to different data types, and it's kind of useful there. And you know, the real kind of killer feature that we're trying to work on is like having a diff. So this is a diff between Tangerine Whistle and Spurious Dragon for the same file. So you can kind of see how a function was removed, two were added. There are still some bugs in this where the navigation doesn't work properly, but we're working on it. So you can actually see how exactly the code changes between hard forks. And one of the goals of the project is to maintain these diffs so that they're incredibly clean and easy for client devs to follow along and implement the changes. And we want to integrate this into the EIP process, like I mentioned earlier. So that's kind of like, we want an EIP to be a text document still, but any changes to consensus would also be specified as a diff to the Python specification. So you can actually see, like, as you're developing a hard fork, you can create one of these rendered documents that describes exactly how the hard fork is going to look like in code. And, you know, do you guys think that's going to be useful? Is this something you'd like to see? If you have any feedback, now's a great time to think about it.
I think it looks awesome, but I'm curious, does it pass all the blockchain tests and state tests, and can you even take this reference code and run throw state tests against it?
Yep. Yeah. So we run the legacy tests right now. We're kind of working our way through getting all of the testing framework set up, but that is a goal. Is we want to eventually use it for filling tests as well. So we want to implement everything we need for that.
Awesome.
Yeah. So we, on the consensus layer side, like PRs for new features don't get merged without tests that would be generated for client teams. So I'm pretty pro getting this on the execution layer side, so that when things are specified, you kind of by default as part of the process have tests integrated.
I just want to give a shout out to Voith, Peter, and Guru, who have been helping a lot with this. Just want to make sure that they get mentioned too.
Yeah, I think this is like a really, really valuable effort on some of the work that's like, yeah, kind of behind the scenes. And I think it would be really nice if we could be in a spot where we do use this to specify kind of the consensus changes of EIPs. And similarly, if consensus layer teams could start using EIPs to specify the English definitions of their changes, so we could kind of have a single system where, you know, EIPs are just like the written text that describes kind of the rationale and overview of a change, and then it just links to a PR on whether it's the execution layer specs or the consensus layer specs, which actually has the technical the technical details, and that will add some EIP editing job for Micah, which he's not happy about, it seems. But I think, and I think the reason, I guess my short argument for EIPs on the consensus layer is they do make it much easier to communicate these changes to a broader set of people. People are like it's easy to anchor, like this change is EIP 1234, and people know that, rather than like this PR to the spec. That's, it's just like an accessibility thing, I think. And
I very much agree. Yeah. Like, and it's not always just a PR. Sometimes it's 6 PRs, right? That so that's even worse. After some subsequent changes. So like mapping that into a kind of a single place to discuss the change set, I think is very, very valuable. So I was gonna say, I do not recommend only having an executable spec and trying to map a what we do in the EIP process to that. I think you need something to accompany it.
Yeah. So I think
in that direction. Yeah.
Ideally we'd have both. So you'd have like just the specification part of the EIP, where possible, would be rewritten as like a Python diff.
Yeah. Okay. I mean, I definitely agree.
Could you, since you can also generate HTML from the Python spec, could you also generate other languages or have a plugin structure to be able to, so that client teams can implement their own plugin to generate their own language, the AIP directly in their target language, and then be able to tweak it to make it work? That would save some typing.
Yeah, I think it's possible. I don't know how practical that would be, and I don't think that's something like me personally I'm interested in supporting. But yes, it's absolutely possible for people to do that. They're regular Python programs. You can do whatever you can do with Python, you can do with this.
Dankrat, you have your hand up?
Yeah, I just wonder if there's a possible future where we have both specs in one repo, because otherwise there will always be this awkward situation with all the any EIP that needs to touch both specs, that they can't really have one comprehensive diff. So that would be fairly nice, I think, but I don't know if that's possible.
Maybe we get there.
I also see the argument for keeping it separate so that you don't encumber these processes until you're trying to do some sort of release. But the cross-layer testing on those cross-layer EIPs, I see the value there. I would like on the consensus layer, Sam and the others that have been working on this have done an awesome job making a more sane approach to doing this, and kind of code first that builds really nicely. And we do want to migrate to use at least the same format over time. The diff functionality is definitely a killer feature.
And one thing I'll add is, I think to echo what Danny says, there's value in trying to keep these processes separate, just if it means we can be a bit quicker. So I think literally 10 minutes ago, we were talking about in the comments, splitting EIPs work from merge work. And so I think even though it's a bit awkward at a organizational level, we do gain a lot of velocity from having the consensus layer split as much as possible from the execution layer in terms of processes. Yeah, so I think if we couple stuff, we want to be really mindful that we don't end up to a spot where we're now even more bottlenecked than we currently are. Cool. We have less than a minute. The last thing is we have a merge community call. Trent, do you want to give a quick shout out for that?
Not much more than what you just said, but it's February 11th, alternating Friday from this call. So if anybody would like to show up and interface with the community, answer questions, we'd be more than happy to host you.
Yeah, so exactly a week from now at the same start time as Allcore Devs, 1400 UTC. Yeah, we'll answer application and infrastructure tooling developers questions about the merge. Cool. Anything else before we go? Okay. Thanks a lot, everybody. This was really, really good. Appreciate everybody's participation.
Thanks, Tim.
Have a nice weekend.
Thank you.
Thanks.
Bye all.
Bye.
Bye. See you.